Hello student, so myself Abhijit. Today I will talk about gravitation. So what is gravitation and why we need to understand it? So let's see it. So why we need to understand it? Why? So why to understand it? So as you can see in the nature, there is earth, there is moon, there is sun, there is everything which is near around us. They are related by something we do not understand for now, but after knowing gravitation we can understand it. So this is the main thing. Why if I drop this, it's going down, not going upward. So this kind of question can be understood by gravitation and gravitational law. So that's the why. Now what is gravitation? So there is like many scientists, many philosophers, they have tried to understand this thing, and like thousands years of understanding after finally the main like interesting formula or main interesting law was given by Sir Isaac Newton. So what he told that, if suppose there is a point mass m1 and there is another point mass m2 and they are separated by a distance r. This is the distance. So then he told that these m1 and m2 will attract each other by a force, and this law was named after him, which is Newton's gravitational law or Newton law of gravitation. What is this? No, he assumed that after his thought and other thing was there, some deep calculation was there, he proposed that this force must be proportional to 1 by r square. That's called inverse square law. He also proposed that it must be proportional to mass of m1 and also mass of m2. So together we can read like this: m1 m2 by r square. So this is the basic assumption he took. So this is clear. So to remove this proportionality, we know that we have to take a constant. So what will be that? So if I write here, so to remove constant, I have to remove proportionality. I have to multiply with a constant and then m1 m2 by r square. So what is this g? We'll understand it after removing this. So what is this g? This g is called universal gravitational constant. What is this? This is universal gravitational constant. Okay. So if you see, this g can be written as, if I multiply with this, so f r square by m1 into m2. So what will be its unit? So its unit, we know the unit of g. So we know the unit of force is Newton, the unit of r distance is meter, so meter square, and the unit of mass is kilogram in SI unit, so kilogram square. So we'll find out it is Newton meter square into kilogram square, 1 by kilogram square. So this is the unit. And what will be the dimension? Now as you know, the dimension of force is mass into acceleration into dimension of length L and divided by dimension of mass square, so m square. So if you do this calculation, you will find its dimension. Now what is, it's a constant and it's a universal constant. Why it's universal, we'll come to that point. But what is its value? So value of G, you can find out, it is G equal to 6.7 into 10 to the power minus 11. Unit is Newton meter square 1 by kilogram square. Okay, so we have understood this constant. Now, so it's a force and it's a fundamental force. Why it's a fundamental force? That's the main concept to understand. So there are many features of this force and we will try to understand one by one. So I will write this thing in this side. So we have found that F is G m1 m2 by r square. So what is the features? First one, the most important one, it is attractive. So this force is attractive force. Why? Because we know in nature mass is always positive. So m is always positive. And distance square is always positive. So r square is always positive. And we found out that G is also positive. So F is positive. So if F is positive, that means it will be attractive. But if you read about electricity, you will find that their charge will be different, like plus and minus. Then there will be attractive, also repulsive force. We will come about this another video. But now first one is attractive. Second one, it's a central force. What is central force? We will come out to that. It is a central force. What is central force? The central force means if the force is in the direction of their joining line. So if force, so this is a force on 1 due to 2 and this is a force on 2 due to 1. So if the force is only along the direction of the joining line, that will be called central force. And one of the most important feature of central force is it is conservative. And you know what is conservative? Conservative means the work done by the force will be path independent. Means it did not depend what is the path of the particle or object. So this is the central force. So conservative. Third point, from here we can find out that F12 is minus F21. So this is from Newton's third law. Newton's third law. We know that force is always equal and opposite. So from there, this is the, and that means F12's mod will be equal to F21's mod. So their magnitude will be same and direction will be opposite. So these are three. We will come out to point number 4. So what is point number 4? That is one of the most important thing, which is that this force will not depend on the medium where this object are. Means it can be in the water, it can be in the liquid of any kind of oil or other thing. In every cases, this force will be independent of that medium. Independent of the medium. That's why this G is called universal. So universal means it's applied to all. Okay. So if Earth and Moon are attractive, that means if there is 2 stars in the universe, they also be followed this rule. So this rule is universal, does not depend in the medium. And 5, which is its effectiveness or its significance, is only for heavy masses. Heavy masses. What's that mean? Now we found out that G is at the power of 10 to the power minus 11. So if G is the power of 10 to the power minus 11, so if mass is very less, then the force will be very small. So it will be like in the power of 10 to the power minus 5 Newton, that kind of thing. then this force cannot be measured in the laboratory. So for that thing, this less masses thing cannot be calculated. So they are only like important for heavy mass like sun, earth, where their mass is very large. And 6, the last point is, this law is valid for point masses. What is that? That is very important. What is mean by point mass and why this is only valid for point mass? Now if the radius, this thing, or I can write it capital R and this capital R1 and this capital R2, if the radius of this thing or the size, I can tell you that size is much less than of the joining line between them R. So I can like that R1 is much less than or R2 is much less. Both, they have to satisfy both. If this thing is true, that means they can be treated as a point mass or as a unit mass. So that's, this rule is only valid for point masses or unit masses. So these are more significant thing you have to understand to like understand gravitation. Now I will do 1 or 2 problem and we will finish up. Okay, so let's do 1 or 2 problem. So hope you are understanding this thing. So let's take one problem and we will finish the video. So suppose there is 2 mass, 2 spherical body. Okay, so there is 2 spherical body. They are like connecting. I have not drawn properly, but you can understand. So they have the same radius. Okay, this is also R, this is also R. So they are spherical and identical, and also they are made of same element. So made of same element. Okay, now the question is, if there is a gravitational force between them, F, then the question is the force will be proportional to what? Like first option is proportional to 1 by r square, second option is proportional to r square, third option is proportional to r to the power 4, fourth option is proportional to 1 by r to the power 4. So as you can see, your first guess will be, it will be proportional to 1 by r square. Am I right? But no, this cannot be the answer. Why is that? We have to find out that. So to find out that, we have to first understand that their mass is not given. So you have to first find out the mass. So they are identical, so their mass will be same, and they are made of same element, so their density will be same. So what will be the mass? We know mass equal to rho into volume. Rho is density and volume. What is the volume of a sphere? We know volume of a sphere is 4 by 3 pi r cube. Okay, so this is the mass. So we have found out the mass. So what will be the force? Force is G m1 m2 by r square. But we know that they are of same masses, so G m square by r square. What is the m square? This square. So G rho square pi square. Okay, 4 by 3 pi r cube whole square and by r. Okay, now we have to find out this distance. So what is this distance? I can call it capital R. So I can call it, this is capital R. Okay, so if this is capital R, then this is R plus R equal to 2R. This is 2R. So 2R square. So we want to only know about proportionality. So after doing all of this, that will be left off. Like if I clear this thing, so F is proportional to, in the above there is a power of r cube square, so it is r to the power 6, and in the below there is r square only, so it will be proportional to r to the power 4. So we have found out F is proportional to r to the power 4. So option D is correct. So that's it for today. Thank you guys.